In this video, we're going to examine Charles's law. So the physical properties of a gas can be defined by four variables: the gas pressure, temperature, volume, and the number of moles of the gas. Charles's law shows the relationship between the volume and the temperature of a gas. So in order to analyze the relationship between volume and temperature, we must keep our other two variables constant. So the pressure and the number of moles must remain constant in these experiments in order to analyze this relationship. So what does Charles's law tell us? Well, it tells us that the volume of an ideal gas changes proportionally as its temperature in Kelvin changes. So if we double the temperature of the gas, as you can see here, we're doubling the temperature, the volume would double as well. And the volume would double in order to maintain a constant pressure. This relationship can be shown here. The volume is proportional to the temperature. As one goes up, the other goes up. As one goes down, the other goes down proportionally. So why does the volume increase when we increase the temperature? Well, as the temperature increases, the kinetic molecular theory tells us that the gases will gain kinetic energy. As the gas particles gain kinetic energy, they will exert a greater force against the container. So they strike the container walls with greater force. In order to maintain a constant pressure, the volume of that container will expand. This relationship can be shown here. As we know, the pressure is equal to force divided by area. So if we increase the temp, the gas particles gain kinetic energy and the force they exert increases. In order to maintain a constant pressure, the area or the volume of the gas must also increase proportionally. So let's take a look at some sample data here from a theoretical or hypothetical Charles's law experiment. In this experiment, we're increasing the temperature for each trial, and then we measure the volume, and we can see, of course, the volume increases as we increase the temp. If we look at the volume and temperature, and we divide the volume by the temperature, we get a constant value. So for Charles's law, if we divide the volume by the temperature, we get a constant value. Graphically, it can be seen here. As the volume increases, the temperature increases, and this can be seen on the Kelvin or Celsius scale, although we always want to use the Kelvin scale when analyzing Charles's law. So as the volume increases, the temperature increases proportionally, and we get a linear relationship, as you can see here. So for a given gas under two sets of conditions, while holding the pressure and the moles constant, we can express Charles's law in a more useful way, as you can see here. The initial volume divided by the temperature initial will equal the final volume divided by the final temperature. So this allows us to calculate any of these variables as long as we know the other three. So let's take a look at a sample Charles's law problem. Pause the video and see if you can solve this. And remember, our temperature must be in Kelvin. Okay, so first thing, let's write down the values that we know. We know our initial temp, T1, our initial volume, our final temp, but we don't know our final volume. Also, I've gone ahead and changed my temperature from Celsius into Kelvin. I've underlined the 8 to indicate the significant figures there. And so we know all of these except for V2. So now we know Charles's law gives us that the initial volume divided by initial temp is equal to final volume divided by the final temp. So we want to rearrange this equation to solve for V2 or the final volume. And we should get an equation that looks like this. Now all we have to do is plug in our data, and I've done that here, and we can solve. Again, be sure here that our temperatures in the same units. Our units of temp cancel, so our volume will end up in units of milliliters. Punching that in our calculator, we get to 3 sig figs, 309 milliliters. So again, practice some more of these Charles's Law problems. Be sure you understand the relationship that it shows and be proficient at solving some of these problems.